Sample for the homework that we had for accelerated motion. Collected this, I believe, well, we started it on Friday, March 10th, and collected it on Wednesday, March 15th. At any rate, the goal for you is to get pretty practiced at writing things down and using these equations and doing the math, because this is something that's not hard if you're in algebra. I mean, you should be able to definitely do this. So these are the two main formulas for this paper. There are different versions of these that I've given you in notes, and on your, hopefully you wrote them on your formula sheet, but these are things where you should be able to do these at this point in time. So problem number 1 dealt with the Tesla accelerating. And by the way, we did a lot of these in class, so you should have all these things written down. General formula, plugging in numbers, answer circled or boxed with units. I also like to write down the known information for each problem because that helps me know what formula to use and how to apply it. So this was asking about the acceleration of a Tesla that starts from rest, finishes at 113 meters per second in 9.5 seconds. So I'm using this formula up here, which is formula 2 on your formula sheet. Plug in the numbers that are given. Be really careful to make sure you use PEMDAS. Whatever you get in the numerator, you should put 113 minus something equals, and then divide that by the denominator. So that gives me 11.9 meters per second squared. To figure out how far the car traveled during this time, you use the second or the third formula over here from your formula sheet, 1/2 AT squared. So you should get 537 meters. Since the car is starting from rest and speeding up, that's a positive acceleration. This one deals with a skydiver jumping out of the plane, falling at this 55 meters per second before pulling on the parachute. Then she slows down to a slower speed over a period of 10 seconds. So in this case, the initial velocity was 55, the final velocity was 5, time was 10 seconds. So again, you need to be careful here. If you just put in your calculator 5 minus 55 divided by 10, basically you're going to get the wrong answer, because you need to make sure you get 5 minus 55 first in the numerator. That equals negative 50. Negative 50 divided by 10 is negative 5 meters per second squared. And because you're slowing down, that's a negative acceleration. For number 3, car traveling at 5 meters per second realizes it needs to accelerate to merge with traffic. So it accelerates at this rate. It's asking how much time for the car to accelerate on freeway with a speed of that. So this is my initial velocity. This is my final velocity. This is the acceleration. So I've got this formula. I'm rearranging it to solve for time. You could basically put all these other numbers in and rearrange to solve for time also. That's just what you do in algebra, solving for an unknown. I mean, that's pretty straightforward from algebra. So I rearranged the equation and got this. 29 minus 5 divided by 3. 24 divided by 3, that's 8 seconds. You could also think of it as, hey, you're starting at 5 meters per second. You add 3 each second. So after 1 second, it would be 5 plus 3 is 8. After 2 seconds, 5 plus 6 is 11, and so forth until you get to 29 seconds. For number 4, you've got a downhill skier in the Olympics, moving at 6 meters per second, reaches a steep downhill portion, and where he accelerates at 4 meters per second every second. So 4 meters per second squared for 8.5 seconds. What's the skier's final speed? So again, we're using this formula 2 and rearranging it. We had notes on how to rearrange it. Either you can know how to do those, hopefully you put it on your formula sheet, or you just do the algebra. Again, not that hard to do the algebra. So when I plug these things in, I get that this final speed is 40 meters per second, and my knowns are over here. For 5A and B, the knowns are the same for both of those. So gravity accelerates all objects at about 9.8 meters per second if we ignore the effects of air resistance. So if an apple drops for 5.2 seconds, how high is the rooftop? Well, we use this equation, which is formula 3. We end up getting 132.5 meters. Notice again, the time is squared. Here, the units are meters per second squared, but here the actual number is squared for the time. So 132.5 meters. If the apples drop from rest, how fast would it be moving? This is again a version of formula 2, the same one we used up here to find final velocity. It starts at 0 and accelerates at 9.8 meters per second squared for 5.2 seconds. So it's going to end up at 52 meters. It actually should be 52 meters per second. So let me put that down. Ugh, that's annoying. $52. Make it purple so no one notices. Meters per second. There we go. Okay, so these last ones here, 6 and 7 and 8 deal with this graph. So this is a velocity time graph, so you've got to figure out about the velocity time. Screwed something up a little bit. Yeah, if anyone listens to this, you'll know. Okay, so at any rate, this is basically saying you've got something that's starting at rest, goes up to 20 centimeters per second, then stays going 20 centimeters per second, and then slows back down. So regions 1 and 3 have any sort of acceleration. This is a positive acceleration, this is a negative acceleration, because the velocity is changing. To calculate that during region 1, you take the slope of the graph, that's final minus initial velocity divided by time. It's 4 meters per second squared. How far did the object go from 5 to 20 seconds? Well, you're going at 20 centimeters per second, and you're doing that for 15 seconds. So that's going to end up being 300 centimeters. And again, I was not looking carefully before I said 300 meters. It's actually 300 centimeters. Okay. During which regions would the object have a positive velocity? And you might think, oh, it's just here in 1. Well, if it's a position time graph, that would be correct. But this is a velocity time graph, and all these regions, 1, 2, and 3, have a velocity above 0. So hopefully that helps. Hopefully you go over it. Hopefully you study for your quiz. If not, you get what you get. So hopefully this did help. Bye.